Good morning, everybody, and welcome to the JKMRC Friday Seminar Series. On behalf of the University of Queensland and the Sustainable Minerals Institute, we would like to acknowledge the traditional owners and custodians of the land on which we meet today. We pay our respect to their ancestors and their descendants who continue cultural and spiritual connections with country. We recognize their valuable contributions to Australian and global society. Today, it's my great pleasure to welcome Humair Nadeem. Nadeem is a policy and project leader at CSIRO with expertise in system dynamics and strategic analysis supporting Australia's minerals and energy transition. He led the development of a participatory system mapping for the Upper Spencer Gulf, engaging stakeholders across government, industry, and community to explore the region's potential to magnetite mining, hydrogen production, and renewable energy. With over a decade of experience across engineering, research, and public policy, Nadeem combines technical insights with systems thinking to inform regional development pathways and support integrated future-focused planning in resources sector. Today, his talk is going to be about participatory system dynamics mapping for regional industrial transformation. Please join me to welcome Nadeem.
Thank you so much. I'd like to thank the SMI team for inviting me. Not too long ago, I used to come into these Friday seminars, so it's a very big honor for me now today to be presenting my work here. Before we move in, I would also like to acknowledge the traditional owners. Since we're meeting in Brisbane, I acknowledge the Turrbal and the Yagara people as the traditional owners on the land that we're meeting on today, and I pay my respects to elders past and present. Really sorry for my voice. I have a kid in daycare, so the throat always acts up. I know this is not the usual, but if there are any pressing questions, please ask me. This is a new field for myself also, so I always enjoy feedback, questions, etc. But before I do that, I'll give you a brief introduction about myself. I am a mechanical engineer by training. I graduated from Iowa State in the United States with a PhD where my focus was on the solid-solid mixing and segregation. So I did a lot of computer tomography work. I did a lot of work in CFD. I did a lot of experiments in trying to figure out what makes solid particles come together, move away from each other, etc. I also have two masters, one from Iowa State University and one from Mustard Institute in the United Arab Emirates, where my fields were looking into petrochemicals, energy, specifically biofuels, and I've also done some work around energy policy. Currently, I am a fellow at the CSIRO. I fall within two different teams. I'm part of the green metals production team. And lo and behold, we have my current boss, Vlad Jokovic here as well, who is my team lead. So you can't really go very far without meeting someone from SMI, can you? And then I'm also part of the Towards Net Zero mission, where we are trying to look at the transitions in different sectors, different regions of Australia from a more holistic viewpoint. And that is what's going to be the focus of my talk today. I'll give a brief outline, as you might have guessed from the image on the first slide. The focus is going to be on the Upper Spencer Gulf, a very unique region when it comes to the opportunities and bottlenecks that Australia has with regards to this new green iron and steel value chain that we can capture. And I'll discuss why it's such a unique region to be looking into, the methodology that we have utilized to look into this region and see how we can help it transform and really extract prosperity out of it based on the resources that it has, is called Participatory System Dynamics Mapping. Again, we'll go into it in a lot more detail, but the first part is I'll describe what I mean by a system map. This is the analytical engine based on which we are going to extract useful information and analyze this region. We are going to analyze it through the lens of archetypal problems, which I will also discuss. And then we'll discuss how those two connect. If you have a systems map, if you are able to map an entire region, all the economies, all the stakeholders within a region, how do you then connect it to this archetypal problem analysis? And what's the useful information that we can extract out of it? And it's useful, and useful to who? Then there are other use cases. While this work started off from a academic interest in the Upper Spencer Gulf, we realized by talking to other stakeholders, specifically in the Tamar Valley in Tasmania, that there are other use cases. Some of them are listed here, and we'll go into a lot more detail of them later. So lo and behold, let's go into the South Australian green iron opportunity. So this project essentially started, as all good projects do, with a conversation with my group leader, Keith Vining. I was trying to figure out, what are the best routes for us to decarbonize the iron and steel value chain. I was looking into Upper Spencer Gulf, and I came and told him, I was like, listen, I feel essentially there are three basic things that you require to have a successful green iron and steel value chain. You need reliable green energy, green electrons. You need a reliable source of hydrogen, which you can, use for DRI and whatnot. And then you need the right type of ore to be able to DRI. And my boss, who has been a geologist since before I was born, I was like, that's mind-blowing. You have actually solved the problem. Let me just call the Nobel Peace Prize people and be like, oh, we have resolved this. But he said, before we do that, riddle me this. If having just a few main things is enough for this green iron transformation, we have all the good iron ore, regular iron ore, but we have all the good iron ore. We have met coal, and we have pretty reliable electricity compared to other jurisdictions in the world. Why are we still not world leaders in steel production? And I was like, yes, that's true. If I don't even know what makes an industry tick, how am I even thinking about transforming it, right? So what are those missing ingredients? If it's not hydrogen, and if it's not the ore, and if it's not the electricity, what is it? What's going to stop, or what's needed to get the Upper Spencer Gulf into a situation where it's a world leader in this green steel supply chain? So we'll look into it a little bit. Upper Spencer Gulf has tons and tons of magnetite, at least theoretically on paper. There's a very good report from the South Australian government. I think it's called the South Australian Magnetite Strategy 2017 or 18. And one thing you will note there is South Australia has 44% of Australia's magnetite resource base, comparable to Western Australia's 54%. But yet it produces only 13% of Australia's magnetite, which is comparable to Tasmania's production, which has only 1% of Australia's magnetite resource base. So you can see there's a very steep divide, and there's a very wide opportunity that South Australia should be essentially being able to take advantage of. A very heavily renewable energy focused jurisdiction. They are supposed to get 85% renewable electricity by 2025, 2026, which is literally now. And they're aspiring to be net zero in the electricity generation by 27. And based on all of these, based on the electricity generation, their aspirations towards hydrogen production, it has also a very favorable policy landscape, something that some jurisdictions struggle with. So then what is it? Is it infrastructure? Do they not have the roads, the NBN, the electricity transmission lines, the water pipes? What's missing there? Or are they missing workforce? Do they not have enough engineers, welders, construction workers, etc.? Or perhaps it's something a little bit more deeper. Maybe what's missing is services. Maybe when they expect to invite all this new workforce in, or as they imagine their industries expand, they need to have sustainable cities. We're thinking schools, colleges, swimming pools, childcare centers, coffee shops, restaurants. So what is it? So in order for us to then look into the whole region, and when I mean region, I mean the whole economy, because everything else is connected, we chose this system dynamics approach. It has basically just 4 main steps. Number 1, you develop a place-based contextual understanding. Number 2, you create a systems map. Number 3, you analyze the system map, you take out useful information, and then finally, you develop collaborative pathways. The reason it's called participatory is It's not just 3 people sitting in CSIRO or 4 people sitting in SMI who is doing this modeling. This is not the traditional kind of energy modeling that you're imagining. This is participatory. The stakeholders themselves, people who actually have skin in the game or expect to have skin in the game in the next 5, 10 years, are the ones who are looking into and developing the maps themselves. By looking at the maps, they're figuring out where they all stand right now, where do they expect to stand in the next 5, 10, 50 years, and what they can do to reach this shared final expected future stage that they want to be in. Developing the place-based contextual understanding usually for us, at least the way we were doing it, depended on reading all kinds of aspirations, goals, literature from the region. This could be policy papers, white papers from the government. Different stakeholders are putting out their climate transition action plans and developing understanding. And then what we did was we, based on that, created a placeholder system map, which we then showed to other stakeholders. This was policy people, industry people, local councils, and we asked them, what do you think about the map? Where do you see yourselves in? And they put their narratives in. So 2 things are immediately clear. This approach is flexible and inclusive, right? I'm going to stop here for 5 seconds. I know I haven't shown you exactly what we're talking about, but do we have any questions up till now? Yes. What do you mean by individual people? The local councils, yes. That's
like business owners that could be potentially developing the childcare centers, the cafe, the services. Can they also be included in this?
so what you hit upon is the third strength of this modeling, that it can be as complex and as granular as you want. The way we have used it, we have come down to a point where we in Tasmania interacted with what's called the Bell Bay Advanced Manufacturing Zone. It's a collective of around 40 major industries. 4 or 5 of them are very big. The Rio smelter is one of them. And we have talked to them. So they all come together and voice their concerns and their aspirations through this collective. And we had chats with them. But if you were a local council, the audience in this modeling, the person using the modeling, is going to change the use case, right? Everyone can use the systems map, but what they're using for is going to be different. So if you are a local council, you can actually go to that point. You can actually imagine going to specific childcares and coffee shops, etc. But there is a trade-off. You want to have just enough detail that you can extract the useful information from it. And we'll discuss this, like, what am I talking about? Like when you have a system map, how detailed it is, and then based on that detail, what kind of useful information you can extract from it. But that's a very good question.
Thank you.
Mm-hmm.
So just a quick question. The 2 places you've shown have big production facilities that are, let's say, struggling. Is that part of your regional choice? Like Temco, Bell Bay is probably in the struggling category, and obviously the Whyalla iron ore system is also in that category. Is this why you've chosen these 2 areas to work on?
As with most good questions, the yes and no situation. We have chosen not struggling regions. We have chosen regions that are actively trying to go through a transformation. The transformation can be self-envisioned, that you are a region which knows in the future you'll have to transition and you have already been proactive. That's a very best case situation. But then whether we like it or not, the whole economy, the Australian economy, is going through a transition, and as the system maps will show, we are all connected. So some regions have transformation forced upon them. So that's how we moved into regions. This project, when it started off, was we're taking a sectoral lens. Our restriction was, and I should have explained this. So when we develop a place-based contextual understanding, and thanks for reminding me about this, one of the things we do is we try to figure out what are our boundaries. So your boundaries can be sectoral, and that's how the project started. Our boundary was we are just going to look at iron and steel. That's it. So in this analysis, you will see that it will be reflected that we don't talk about childcare and workforces too much. But then we realize that the boundary has to be expanded. So You develop a sectoral boundary, what regions, what industries are needed to be part of the analysis. You develop a geographical boundary. So for us, we selected Upper Spencer Gulf, but what's to say that we don't select the whole of the state? We selected Tamar Valley. That's because the local councils there form a collective. But it could be a state, it could be national level, and that will change how granular your map is. And then we also have temporal boundaries. How far into the past are you looking into, or are you willing to look into, and how far in the future are you planning for? All very good questions, and I'm 100% sure a lot of them will be answered in the next slides. Place-based, contextual place-based understanding. These are all some of the many documents we went through for us to develop a place-based understanding. It's very, very difficult to go into a region and come from a place of, I know what the region wants. So it's very important for us to first have an understanding of what the stakeholders of the region are, at least publicly, churning out what the public positions are. So then you can start off a placeholder map. Before I go into a map and I start showing you a map, I'm going to give you a very quick crash course. Is anyone familiar with systems map before? Have they? Okay, so very big crash course. What you see on the screen here are three variables: birth rate, population, death rate. We all know they're connected. Agreed? All right. How are they connected? The higher the birth rate of a place, the higher the population. The higher the population of a place, the higher the birth rate. So these are positive feedbacks. Are we agreed on this? Now, because higher birth rate leads to higher population and higher population leads to a higher birth rate, this is a reinforcing feedback loop. If left to its own devices, it's going to be a runaway exponential growth situation. But God does not like that, so he gave us death. We know the higher the population, the higher the death rate, right? More people living in a city, more people will die. I would know I'll come from a city of, I think, 22, 23 million people. My city is larger in population than my wife's country. So I'm come from Karachi. Okay, so, but the higher the death rate, the lower the population. So this is a balancing feedback loop, right? The interactions of these feedback loops are going to tell us a lot about how the economy, the region is going to behave. There's a few more things. Not every variable you see, not every connection you see will be part of a loop. So for example, we know life expectancy is going to have a negative effect on the death rate. The higher the life expectancy, the lower the death rate. But this is not part of any loop. And if you see those two double lines anywhere, that means it has a delayed effect. So just because there's an increase in population, doesn't mean immediately you'll see a decrease in death rate. It might take some time to go through. That's all you needed to read a systems map. This is just the overview of a system map. I know it's a very ugly image, but it's just an overview. And this is where your question comes in. We are just looking at the overall region for now. We haven't gone into the nitty-gritty. But we can see some very reasonable connections forming. If you want industrial decarbonization, you need to have green steel manufacturing. For you to have green steel manufacturing, you need to have magnetite mining. What else? If you have a lot of availability of workforce, there's going to be a move towards FIFO, very reasonable there. And you see a collection of reinforcing and balancing loops forming. We'll lift the hood. If you think this is as bad as it gets, it's even worse. That's just the industry section. We are just looking into magnetite mining. And like I said, we initially only envisioned a sectoral lens. So it's only construction for infrastructure, magnetite mining, and green steel production, right? And ugly, ugly drawing. But it shows us these connections. And you'll see these colorful bits and pieces, the hexagons. These are what we'll call archetypal problems, sorry, not systems. But I don't want to show you the diagram just for nothing. Before we start synthesizing useful information from those maps. So you've seen the map. You see how it looks. I'll promise you there'll be simpler images later on. But let's delve into what are these archetypal problems, right? So you have four horsemen of the archetypal problem. And when you're looking into the different types of problems that can arise. Number one is unanticipated side effects. You saw a problem, you went to solve it, and usually, like my 2-year-old does, makes it worse, right? So that it could be a fix that failed, or it was a situation that reduces the ambition of doing real structural change. You put on a Band-Aid and you kept on putting Band-Aids, and ultimately we came to a final stage where the problem is worse off than before we wanted to start. We could have a time delayed response. Either the ambitions to solving a problem, to doing a transformation, those ambitions fail over time. Think cycles like elections. It takes takes too much time. Sometimes it goes out of your mind. The other is a problem exists, but is so far ahead in time that you downplay it. By the time the problem arises, all the progress that you've made is gone. So we are thinking of situations where you end up worse than how you imagine the transformation would look like, right? Another set of problems could be path dependencies. You are in a situation where we are all in this situation as researchers, technologists, we are all trying to develop a solution. Sometimes one solution works really good, and then all the effort starts going into that one solution, which may not be the optimum solution, right? So we can fall into success to successful. It could also be a situation where many solutions existed for some reason, and again, we are assuming that we select and try to add to an optimum solution, but it could be political will, economic reasoning. A solution is selected, and then that leads to escalating tensions with people who were developing other solutions around you. Does that make sense? It will in a bit, don't worry. And then the last one is limiting conditions. And this is the one that we are most familiar with. Limiting condition is, in order for us to go through a transformation, or in order for us to reach a better final stage, we need to use some resources. As we start using the resource, the cost for using that resource goes up, and now you are not able to get the same amount of progress with every unit of effort that you're adding. So that's a limiting condition. And you could also fall into a tragedy of a common situation where everyone wants to use the same resource, think water, think renewable energy, and you collapse the system. There's a more focused understanding of these in Mollamy 2021, I think, who talks about these unanticipated side effects, time-delayed responses, what they look like, examples, etc. So we won't go into a lot of detail here, but there are basically what I'm trying to say is there are 8 different types of archetypal problems. And if it's an archetypal problem, then there's going to be some form of solution. So when you synthesize information from your system map, when you look at a problem, when you figure out that this is a bottleneck, you are able to characterize what kind of a bottleneck it is. And then you also can figure out together how you deal with this type of bottleneck. The remaining 4 are here: path dependencies, escalating tensions, limits to progress, tragedies of commons, etc. Here we are looking at the workforce set of this map. The way I envision this map is, my map has all of these different cross sections. There's an industry cross section, there's an infrastructure cross section, there's a workforce cross sections. And you will see at the top, there are some variables which are slightly grayish. Those are shadow variables. That's what we call them. But they are the connectors. Their actual further information is in a different cross section. So if you're looking in workforce, you might see some shadow variables, which are not shadow variables, let's say, in industry. But that's your 3D map, and I'm showing you cross sections from that, and the connections between those cross sections are those shadow variables. Does that make sense? All right. As I promised, I won't show you those ugly Vensim diagrams anymore. Vensim is a very good software for modeling, horrible for presentation. Not that this is any better, but this is my attempt at making those images better. From the map, now this is just the workforce. Very quickly, you know that if you think that these are the different industries, R1 through 6, these are the industries that should come up for the transformation of the Upper Spencer Gulf. They, we know, will include hydrogen, mining, magnetite, et cetera, et cetera. They're all going to put a positive pressure on workforce demand. Workforce demand is going to lead to attraction for labor in the domestic market. That can be fulfilled in two ways. Either you slip into FIFO or you actually make an effort and do some local community building. I come from the States. The whole of that region is full of small towns. Those were either mining towns or railway towns. We don't see that here in Australia because we have FIFO. So, and then that finally goes back to workforce availability. Whether you are fulfilling your workforce from FIFO or from local community building, that puts a negative pressure on workforce. Sorry, it produces a positive pressure on workforce availability, which in turn brings down the demand. But these two are balancing loops. The one in the middle, R1, that's the critical one, because the more FIFO you have, the less community building you will have. At least there will be less ambition for having this local community building because you are already solving your immediate problem. In a competition between short term and long term, generally speaking, short term always wins. So this can lead to negative outcomes for the region, right? For people who are living there, and you find this in it's often not appreciated, at least not from me as an engineer. I don't really appreciate how critical of a problem that is for the local councils, for the people who have been living in that region for millennia. It's very difficult for Tasmanians, for example, to see their kids going to the mainland and not having those same family units around them. Anywho, so this is a band-aid solution, right? Archetypal problem. We can imagine it, we can see it. It's an evidence-based boundary object over which different stakeholders and policymakers and large and small industries can come together and co-develop pathways to resolve this problem. I'm not telling the regional stakeholders what the solutions are. I'm telling them, look, this is a way, this is in front of you. The whole map is there. You can see how you connect, how your operation is going to affect the next person's operation. And this is what it will ultimately lead to if we go in a do nothing scenario, right? Another one is, as you have workforce demand, there's going to be demand for people who certify, who train, who instruct the upskilled workforce. That requires a lot of investment in the education sector. Believe it or not, it is a bigger problem than, again, I imagined it. In Tassie, some of their workers are actually trained in Queensland. And that's a problem because they have a very different kind of work culture. They're working more with forestry, etc. And the workers here are exposed to different industries. So there is a disconnect that happens. And even though officially you are trained and certified, you have to go, and the local businesses then have to put money in to retrain the workforce. This is a downplayed problem. We know this problem will exist. If you imagine the Upper Spencer Gulf to become some form of green steel superpower, we know that the TAFEs and the universities and the education sector there has to be very, very strong. And this cannot be when the industry is there. These are discussions to be had earlier, right? An example of downplayed problems. We'll go through a couple more of these archetypal problems. This one is very simple to understand. The first one is what I discussed about limiting problems. Sorry, I forgot I have this. Let's say the technological solution has been found, and we are all steam ahead, going towards producing green steel in the Vayala again. There's going to be energy required, water required, and as you start ramping up your green steel production in this region or within Australia, energy consumption and water consumption will increase. The more of it's available for use, the more green steel production can be unlocked. And the negative effect would be the cost of energy consumption and the cost of water consumption will go up, right? So what can be done? I don't know. Perhaps as we are ramping up the usage, we also invest in the energy sector. But this is a very good example of limits to our progress, right? And the next one is, and this is also very familiar to us, is let's assume magnetite mining has been unlocked in the in the Upper Spencer Gulf. There are no issues with water, etc. The more magnetite is available for export, the more of it will be exported. And the more of it is exported, then there will be higher and higher allocations of magnetite being produced in the region to be exported. So we go the way of Western Australia. And the more of the magnetite is allocated to export, then there is less available for local steel production. And that will have a negative outcome on local green steel production. As local green steel production goes down, because there's less magnetite available, there will be, what do you call them? I forgot, sorry. There will be some sense that local demand is falling because local production is falling, and more of it will be allocated to export. So you see, these are two reinforcing loops, reinforcing each other, and this is a success to the successful situation. Do we have a question? Go for it. Oh, okay. All right. If it's not something to share, then it's fine. But if you are getting some funding, you can have a chat with Ladge. we're always invested in helping. All right, one more. Water usage. We all know the Upper Spencer Gulf. One of the biggest problems there, depends on who you ask though, is water, right? Each one of these empowering industries, magnetite mining, steel making, hydrogen production, is going to be very, very heavy on water usage. Plus, all the workforce that we're expecting to come in, whether it's FIFO or it's from local community development, is going to have its own water usage increases. Think domestic water usage, swimming pools, community centers, etc. All of those are going to do what? Let's just take one reinforcing loop. The more hydrogen production there is, the more water will be used for hydrogen production. And the more water is made available for hydrogen production, the more hydrogen production can go up. So this is an example of a reinforcing loop. Four reinforcing loops all going into increasing water demand. What's that going to do? That's going to push the cost of water consumption to go up. And that's a limit, an individual limit to progress for each one of those. But together, it's the quintessential tragedy of the commons. What that leads to is an unsustainable water resource in the region. Think droughts. We're just discussing about droughts in the region, not having enough water, etc. So up till this point, what we have discussed is we can create a system map, a participatory modeling that's inclusive, is flexible. It is not designed to be an alternate to energy modeling or any other resource modeling in the region. It's designed to bring all of it together. It's not going to give you an exact number. This is the amount of hydrogen you need to unlock green steel production. But it can give you very good directions of where you're going. And the specific use case we utilized with the sectoral lens hats on gives you a very good idea of the archetypal problems that you will face if you have that trust building with the stakeholders, the big players in the region. You can all sit together, figure out, yes, this is where we see ourselves. Yes, this is where we stand. What I'm trying to say here is, for example, let's say water. What is the problem? But if it is temporally diverse, right? Like the hydrogen industry is coming online now, the steel industry is going to come online 10 years later. So those are the kinds of conversations that can be had around the systems map, right? And those are the kinds of solutions that can be extracted by really understanding what your archetypal problem is. So it's about empowering stakeholders. And I continue to use the word stakeholders, not policymakers, because yes, a lot of the conversations were had with policymakers, but this is a tool to be utilized primarily by everyone who thinks they're going to be a part of a region, a part of an economy, and that region or that economy is going to affect them, right? At the end of this set of my project, we looked at the systems map and we thought that there's a lot of potential here. Maybe there are use cases that we are not saying. What else, right? Sometimes you have that, right? You have a technology, you have something that you're like, there can be more extracted from it. So we had the opportunity to show, develop and show a systems map to the Tema Valley people. That's another interesting region because we, even though this project came up through minerals processing in CSIRO, we realized that there are other teams who are working with other regions which have very similar problems, right? The Tema Valley, we just discussed, is a very diverse region, has its own challenges, is all going through its own transformation. Similarly, Queensland's sugar industry is looking for new avenues, new markets. It's very involved with biofuels production, trying to find space to create bio precincts to up themselves in the value chain and create better quality and better products. So how can we help them? So we do, like I said, I'm going to repeat myself, but a very diverse economy. Tema Valley is, if you have not visited, it's one of the best places to go. I don't drink, but I've heard they have very good wine. They have their renewable energy systems are very unique. They are they're built on hydro. So there's a very different resistance to renewable energy. It's not that they don't want to be more sustainable. They're like, we already are, right? So a different kind of conversation happens around that. The Marinus link is another thing that's really connected to their power system. The industries are grounded by the Bell Bay advanced manufacturing. And like I mentioned, forestry is another industry that's really important in that region. And it's not that strong anymore, but it is very intertwined with the heritage of that area. So it is one of those industries that should be protected and saved. Anyway, so we had chats with 11 different stakeholders, all the way from the Office of the Coordinator General in Tasmania to the Launceston City Council, RDA, that's a collective of the city councils there. You're talking about city councils. We had chats with them, and RECFIT, their renewable energies and transmissions and whatnot people. And every one of these stakeholders, it's very empowering to see, brings their own flavor. Councils are more focused about housing and garbage and water collection. Someone is more focused on around workforce. Tasmania, is just a fun thing that I found out, has the same number of people coming in as it has people leaving. So net migration into Tasmania is, according to this person that I had a chat with in the government, is in the double digits. So there's like 20 people difference between the people leaving and people coming in, right? It's just one of those things. But unfortunately, a lot of the people moving in are not Tasmanian natives. And a lot of the people moving away to the mainland are Tasmanian natives. So that's just one of those things. You can't really put that into a modeling, can you? Anyway, so those people came up with 4 different use cases. One is to, and this is government people, right? So you'll see a lot of government flavor here coming in through. They said, we can use it as a scenario pathway analysis. The minister will ask, okay, what can be done? What does the future look like? Oh, let's do this, let's do this, let's do this. So you can present 3 or 4 different pathways to someone with all the trade-offs, the pluses and the minuses very clearly articulated. You can see it as a risk analysis tool. So if you are a hydrogen producer in the region, you know where your water is coming from, you know who else has claims on that water. So it creates a 3D risk analysis of traditional, we have, when we imagine risk analysis, we are like, that can happen, that's the probability it will happen, and that's how bad it will be. But this creates a 3D view of that. A policy coherence and coordination support tool. Another thing which I learned through this project, I always imagined government to be one big monolith, but it operates very similarly to universities, and every department had its own thing going on, and they're churning out their own white papers and policy papers. This gives them an understanding of going back a sec and figuring out, okay, you want electric cars to come through, and you are trying to push for biofuels. Do these 2 policies gel or not, right? They might be coming, and these policies could be coming from forestry, electricity, totally different departments. And you'd be surprised how much people don't talk to other people. And then stakeholder engagement, right? It's a very good tool for different collectives to come together, co-develop solutions. And also it can be used to create trust with the public, right? Either when we're going to the public, we are trying to educate them, right? Or we're just giving them a few options. But this kind of a modeling can allow the public to go through some of the pathways, scenarios, risks, benefits themselves, and make educated reasons, educated understanding of what they want to see the future as. So it can help in collecting consultation from them also. So I'll just go through very quickly. So this is a scenario pathway analysis. Just wanted to give you an understanding of what I mean by a pathway analysis. This is what the Tasmanian power supply looks like right now. Most of it is from hydro. That's what leads to their total electricity generation. Their demand supply gap is based on how much they're producing and how much they're exporting. And if there are any shortfalls, it's filled with gas. Easy peasy, lemon squeezy. But is this the only, this is the do nothing pathway. Is this the only pathway that exists? No. We can have another pathway. All of this in the middle is the same as before, but we have unlocked a few more pathways by bringing in the forestry resource and hydrogen production. So if forestry can provide forestry residue, etc., and you have hydrogen production, you can create a whole new market around low carbon liquid fuels, which can become self-sustaining at some point and can also help with electricity demand, because now you're not trying to electrify the entirety of your transport. For example, maybe the ferries are all on low carbon liquid fuels, or the buses are on low carbon liquid fuels. So that also helps with your energy demand supply gap. So that's another scenario. That's the LCLF scenario versus the do nothing scenario. This is the map you have seen already before. Just wanted to highlight that these are choices that we make. If you are setting up policies and you're focused on bringing in workforce through FIFO, or if you're focused on local community building, those are two very, very different policy levers. If you're FIFO, who is your stakeholder? The airport. You're thinking about expanding the airport. You're thinking about talking to Qantas and Virgin to bring in these regional flights. And if you're doing local community buildings, then the stakeholders are different. The policy levers are different. You're talking to councils. You're talking about housing. You're talking about bringing in universities. So that's what I meant by policy coherence tool. We already talked about creating a 3D understanding of your risks from a 2D understanding of your risks. And I've already mentioned the stakeholder engagement consultative bit. Just being cognizant of time, I'm going to stop my presentation here. And I assume, and I hope, there's a whole ton of questions.
Thank you, Nadeem. Questions? One from his boss.
Thank you, Humair, for the presentation. I mean, mentioned I've been boss. I've been bad boss, but definitely this is the first time I'm seeing this. So, excuse me, my stupid question. You mentioned that you have 3D maps, and you are describing very complex dynamic system, and there's a lot of positive negative loops there. So I guess when you run the simulation, the system will go into different outcomes, unstable solutions, and everything. So do you? So to me, it looks like how you tuned those feedbacks are really determine the outcome of the simulations. So how do you use those? Does that mean that, I mean, how did you, it's not really validate, how do you make sure that the outcomes of simulations are meaningful? Thank you.
So that's actually a very good question. And that also brings into some of the capabilities of the map. So if you have noticed, I didn't say participatory system dynamics modeling. I was continuously talking about mapping. So this type of mapping has the potential to take in quantitative data. And as you start putting in quantitative data, you need to have good relationships between the data. Your data has to be good. The relationships have to be good. That is not what we're doing here. This is supposed to be a qualitative approach for now, because the idea, and this is some of the responses we were getting specifically from the government sector, they don't really need specific numbers yet, because they have entire dedicated teams, right, that do this kind of modeling. The idea is not to replace the modeling. So there is no press a button and see what it turns out happening. It's more about connecting all of it. And then some of the, and it's a what's the word? It's a feature, not a bug, because we wanted to capture stuff that we were not being able to capture with all our different kinds of technological modelings. Think about people's perception towards nuclear energy. How do you quantify this, right? The attractiveness of some technology, the attractiveness of setting up parks in a region. A lot of that is qualitative data. It goes into the decision-making process, but cannot necessarily be quantified. And if it cannot be quantified, usually what happens in these kind of modelings is it's either removed or some form of average is put in. That's not what we're trying to do here. So there's not a modeling aspect yet. It has the capability to be expanded into that, but we need a lot of resources for that. We'll need a good case study for that. And I think we'll have to change our scope quite a bit. We'll have to go to a couple of industries where the data, we have a lot of confidence in the data, and the data has been taken for a very long time, so we know what the connections of those variables with that data is. But the scope of this is regional level. We are trying to capture the whole of economy, and unfortunately, there's a trade-off. You can either capture the entirety of an economy, right, or you can get very accurate results. Is you can't just have both, if that makes sense. But that's a very good question. I think we have one more before you.
Thanks, Humair. That was fascinating talk, and apologies for interrupting you with my whispering
No,
before.
no.
What I was whispering to Nick was about the Cloncurry district specifically. That's got one of the larger concentrations of magnetite in the country, I would guess. Whether anyone's looked at this kind of mapping for developing a green iron industry in northwest Queensland, you know, if anyone's had a look at that, and particularly with reference, there's the copper string, a green energy corridor being built, or at least being permitted at the moment, from Townsville to Mount Isa to connect that area to the grid and add a lot of green energy to that corridor. But I was wondering if that opportunity has been assessed on any larger levels that you know of.
Not to my knowledge. I know systems map have been used to map national level sustainable development goals, etc. And we are sort of adapting that already established methodology to trying to gain insight from transitions to net zero. I know there's a regional, industrial regions network that's active. So some of my co-authors, Jody Bruce, for example, is very active in those, but I'm not sure if that region is one of the regions that they have identified. No, I'm not sure if that region has been identified as one of them. And we would definitely be invested in doing that work. It's just that we have to create a project around it. That's how CSIRO operates. Unfortunately, we have to create a project around it. We have to figure out who the stakeholders are. Sometimes it's not just a matter of studying a region. This is participatory systems mapping. So we want the stakeholders there to be involved. Some of the work that we did, for example, in Tasmania, was not led by us. It was led by the Tasmanian Policy Exchange. And by led, I mean, we didn't identify that region. They identified. We were having a presentation on the Upper Spencer Gulf, and they're like, can you bring it to us, please? So that's how that project came about. But yeah, I do understand that that's a very interesting region to have a look at.
And as just a quick follow-up as well, with these participatory systems maps, are there numbers underlying what you have there? Like, can these maps then be kind of merged or turned into a structural economics model?
That is the next step for them. So we have, CSIRO has something called NEAC. I just don't know the full form. Do you remember the full form? NEAC? It's National Modeling sort of database. And the idea for these kind of maps is we have modeling data that comes out from many different resources, and how do we collect it all together? So right now, as how I have presented to you them, there aren't. If there were numbers, we have brought them down to a plus or a minus, right? Does this increase something or does this decrease something? And that's why I was showing you all those different documents that we have talked about. So that's how those pluses and minuses came about. That's the extent of it for now. The idea of this systems map is we'll create a central database. a very modular database where different types of modelings can come together. So perhaps you are a stakeholder who's only interested in energy modeling and economic modeling. And this can connect just those two, but someone else is interested in other things, and this can connect all of those things as well. So that's a work in progress, and CSI is working on it, from what I understand. Yes, sorry.
No worries. My name's Andrew White. I work in communications here at SMI. So could you expand a little bit on how velocity factors into these maps? For example, like FIFO and expanding an airport is probably quicker than building all the infrastructure and housing and education.
Yes.
So what you talked about velocity being factored into the 3D map, but how does that factor into those maps that you were showing us in terms of the pressures?
So I wouldn't phrase it as velocity. It was just a, what was it called? It was a delayed response, right? So it's just that if you do something, like you said, if you have an airport and it's ready and it's expanded, you can have workforce coming in essentially, ideally tomorrow. But local community building is a much more, on a much more longer time frame, right? For example, Tasmania operates something called Brands Tasmania, whose main job is to identify Tasmania as a place for people to come in and live. But you can imagine that that's a project that spans many years, and that does not mean that tomorrow there will be 3 plane loads of people coming in. It will maybe start off as a trickle and then reach a critical mass. So that's how we figure out whether it's a delayed response or if it's an immediate response. So I wouldn't say there is speed. There's no sense of velocity in it. It's just that I pull a lever. Can I see its response immediately? Or do I expect it based on the temporal timeframes that I have initially envisaged in the map? Do I see a response immediately, or do I see it over a longer period of time with respect to the timeframes that we have already identified as system boundaries for the map? Does that make sense?
Thank you.
Hello, my name is Christian. Thank you for your presentation. My question is about, you have some time interval in which you did the analysis, right? Is it possible that some of those loops that are positive feedback become negative within that time frame? And also, the second part of the question is if you can create and destroy new interactions between.
Christian, your name was, right? Yes. That's actually one of the best questions that I've had today. Because if you know, roadmaps is not something that's new, right? We all have seen roadmaps for this region, roadmaps for that region, national roadmaps. So the idea here, you are exactly right, Christian, is to have a living roadmap. The whole idea is, the reason why we have it participatory, and we want stakeholders to not just engage with the map, but edit it, create it, and over time, figure out where are we. So yes, you're right. That's the design of it. That's not a secondary capability. That's literally the main selling point. That assume you're a BBAMZ and you see the map and you realize we need X, Y, and Z by 2040. Come 2030, you have decided not to follow X. You are very far ahead on the progress of Y, and Z is no longer economically viable. The system map changes, right? Variables can go off and on. And that's what we're trying to capture here, right? We need a set of modeling that can capture what happens after an election, right? And I'm not talking national elections. Sometimes council elections very significantly change the region's progress in any one direction, right? What happens about, the perception of the people changes about something. A new industry enters a region or leaves a region. These are things that are happening simultaneously. Since I started working on this, all the news you're hearing about the hydrogen in the Upper Spencer Gulf, those projects being, how do we say it, postponed, or their timeframes expanded, or the situation with Vayala. This work emerged before that. So we were working on this and things were actively changing while we are doing that. And that's what we want. We want the stakeholders to be able to take bits and pieces of it. I showed you many different cross sections. Maybe the stakeholders don't want to even have an entire cross-section about industry. It's an ag-focused region, for example. Does that make sense? So that is literally, you have hit it right on the head. That's the capability that we are trying to produce with this kind of mapping work.
Hello, Shujat here. Great talk, Humair. Very much related question. So in your systems map, so when you do that modeling, so there are lots of synergies between different factors there. Have you done any sensitivity kind of analysis in that space that basically demonstrates in future if something changes, how would that impact the overall outcome?
Again, so that leads back into Vlad's initial question. And I struggled with this also quite a bit initially. I have been a CFD person. I imagine to have all of those questions come up, sensitivity analysis. This is this type of work came up from, if I remember, from social sciences, from the Club of Rome. And they were trying to figure out if there's a very seminal work called Limits to Growth. So where they talk about, and it was very controversial at the time that this kind of growth that we're looking into, we're talking about the 70s. The exponential growth, technological growth that we're talking about is going to lead to a collapse of industry and etc. So the work stems not from engineering. So all those kind of questions would not necessarily apply. Sensitivity analysis I would be able to perform if this was some form of quantitative modeling. What happens if I change this variable by 5% and I change this variable by 10%? Does my result change by 6% or 20% or whatever, right? That's not what we are imagining here, right? Like I said, there are trade-offs that we need to make, right? A model as complex as this, I'm talking off the cuff here as a former modeler. With so many variables, right? Would you really have faith in the final results? Right? 1, 2, 1, 2, half percent error in each variable, each connection. One point of bad data, and we know there's very, very, very bad data out there, right? And would you really have a lot of faith in that kind of quantity coming out? It's not designed for that, right? It's not designed for that. Like I said, it's an iterative, flexible, inclusive mapping modeling method, which can bring people to the table, identify strategic limitations, strategic bottlenecks, tailwinds, headwinds, and make changes accordingly. And then it can be supported. So if we do some changes, for example, hydrogen comes online and we see some parts of the map lighting up, there are other modelings that are being done that can support this map. How Christian was saying, what happens if something changes or a positive becomes a negative? How would we know that? Some other modeling, some other experimental work would be informing us that, and the map will change based on that. Does that make sense?
Yeah, it does. Perfect. Thank you.
Do you have another? Last.
Thanks again for a great talk. This may also go slightly into that quantifying things, but
Yes.
I'm trying to keep it away from that. So in what I guess we can call the post-truth reality of the world, and you've got stakeholder engagement to make your maps, I assume you could potentially have people with diametrically opposed, I guess, causes and effects for your different things.
Yes.
Or we can look at it maybe not in quite such an extreme case. But so how do you account for that? Do you have some level of sanitization also to potentially minimize, the sheer number of causes and effects so that you're choosing what you consider the greater ones? How do you handle that? Or did you not need to in your case, if you were lucky enough not to have to?
Two questions, both of them very controversial. I'm just trying to find the right words for them. I deal with the second one first. Limiting the map, how many connections to make, how many not to make. The idea there is you make as many connections as there are need, right? Based on the audience and based on the use case, right? That's what describes you things. For example, in the Tema Valley, like I showed you, there are very many diverse industries that are all acting together. But in the systems map, you didn't see The Marinus link, for example, or I think maybe it was there, but it was there just enough. So that is what will dictate. You obviously, as a modeler, you want to have as simple of a model as required. Plus, with this kind of modeling, like I said, audience, are you using it for stakeholder engagement with stakeholders having a good understanding of this kind of a process? Have you workshop with them? Or are you using it to elicit public response? This is not a map that's going out in the public, right? That's going to create more problems than already exist, right? So that's why I showed you that overview map, right? So you can perhaps have that overview for eliciting public response. You can have deeper ones for people who are actually part of the process, who are, so we're delving into your first question, the more controversial one, who are seeing themselves in the map, right? This is where I stand. This is what I need. This is who I believe I'm connected to. So perhaps for them, you will have a much more complex and a much more detailed map with a lot more connections, with a lot more variables. So that's that. The diametrically opposed one is a difficult one. As CSIRO, we are very focused on evidence. We are generally considered to be very trustworthy. So there is some level of trust when, like I said, it's a participatory process, right? If someone is not willing to be part of the process, we can't force them. So by design, the way this research process has gone forward, we have only interacted with groups which are invested in their future state, and they want to have a say in their future state, and they want to understand what's best for them as they move towards that future state. You could have a situation where people are diametrically opposed, and in those cases, I think this systems map is the conversation around this systems map is even more important to have, right? If you have stakeholders in the area with very diametrically opposed views, and they're sharing resources, they're sharing connections, their operations affect other ones, those conversations need to be had a lot earlier, right? So that's where I would put that answer, that it is still a evidence-based. So this is not, okay, let me talk over this. Let's say me and Eric, diametrically opposed, right? And we want to create a systems map. Me and him having a general chat and saying, I want hydrogen, and he's like, no, I want hydrogen. That's not as conducive to a reasonable solution as if we both come together and say, look, this is the map. This is what your situation looks like, and this is what my situation looks like. Because what we are doing is, if we have a connection and we are diametrically opposed, we are creating risks for each other, right? There's already risks in the regular day-to-day doing business. There are additional risks added as different regions are going through a transformation or a transition. And we don't know what that future state looks like. It's not a linear situation that right now we are here. This is what my region looks like. This is my electricity renewable percentage. This is my this. These are the industries that are open. And then suddenly, boom, we are moving. We are actively building that future. So these are risks, business risks that we are taking. So I think it's a good center point to have those discussions. I will stop my answer there, but we can have further chats if that's okay.
Well, thank you. Please join me to thank Nadeem. Well, next week we have Richard Glogwin from Home Health Institute Freiburg for Resource Technology, talking about non-invasive technologies for metal resourcing in sustainable society, a spotlight on European funded projects. So please join us next week. Thank you.